Hey everybody, my name is Jordan and I'm going to be going through the workshop with you today, porting your first Solidity application to Nervos. So what we're going to be doing is we're going to be taking an extremely simple Solidity application that's running on Ethereum and we're going to be converting it over to Godwoken. This is very similar to task 7 from the part 1 of the hackathon. If you took part in that, this is a very similar thing, but it's a little bit more simple and it's a little more updated. Godwoken went through a couple changes, so we made some changes for that, and we took out React to simplify the code base even more. Now there's no React, there's no TypeScript, it's just basic JavaScript and HTML. So the first thing we need to do is clone this repository right here. Okay, so if we take a look inside of it, it has the Ethereum simplest directory and the Godwoken simplest directory. So these are the two different versions. The Ethereum version is the one we're going to be going through, and the Godwoken is basically where we're going to. That's what we're trying to convert it into, and we're not really going to go through this. Is just provided, so if you wanted to take a look at it for reference later, you can. It's in the repository. We're going to be working with Ethereum simplest and converting it actually over to into the Godwoken version. So if we open this up in an editor, let's first take a look at the HTML file here. This is the basic page. It's extremely simple, just a single JavaScript bundle include. We just have some basic data on the page, which has these empty hold span tags, which we're just going to populate. And then it's just got two buttons over here, a button to set a value and a button to refresh the values. There's really not much here. And then if we open up the JavaScript, it's a pretty small file. It's under 50 lines of code here. Just the very basics of what we need to get a page up and running, pull in a value, and set a value. Okay, so we're going to first work with the Ethereum simplest. First thing we need to do is initialize the dependencies. I'm using NPM, but Yarn should also work. And then we start the local dev server, and we can open it up in the browser here. Oh, and so one important thing I should note is that I've already set up some accounts here that I'm going to be working with. These are accounts that I've set up on Rinkeby, and I've also set up accounts in Polyjuice. And so this corresponds to things that were done in tasks 1, 2, and 3 of part 1 of the hackathon. So those are still available. This repository here will have all of the tasks still there, and we're leaving that out there for the time being, and we're continuing to update that as well. Just because that was a really good source of information, and later we'll formalize it and move it into some kind of a documentation system, but that's where it is for now. And so I'm not going to be going through these parts because that would be kind of redundant. The steps are exactly the same as they were in the tasks. So I've already deployed various contracts and set up accounts with testnet, Ether and testnet CKB that I'm going to be using for our demonstration today. Okay, so going back over here. So this is my Rinkeby account, which I've already set up. It has a little bit of Ether in there. Here's the address, and here's the contract address. This is a simple storage contract, which is the same. It's the same exact contract that was used in part 2 and part 3 of the previous hackathon. The simple storage is pretty much the de facto example for most Solidity starting points. It allows you to store a number and retrieve a number. There's barely anything there. It's the most simple contract you can have. So we're just working with that. And so right now it has the contract in it has a value of 1. And so let's set it to 2. not sure what's going on here. Sometimes I've had it take a while, and I'm not sure why. So let's just refresh the page here and try it one more time. There we go. Now this time it came up really quick. Okay, so at this point we're still looking at Ethereum only. We have not touched anything or made any changes for Godwoken at this time. Okay, so we can go ahead and convert this or confirm this transaction. So now it's been sent, and we're just waiting for the transaction to confirm. Okay, so it's confirmed, and it's popped out a link here. Now, sometimes Etherscan is a little bit behind, and sometimes I've noticed Etherscan is a little bit ahead of what MetaMask thinks. So sometimes you got to wait a little bit here, but usually most of the time after you see this transaction here, shortly after, you should be able to click refresh, and then there we can see that the new value came up. Okay, so before we start with we go into Godwoken, let's take a look at what actually went on here with Ethereum inside the Ethereum code. All right, so first we import the Web3 library, and then we have the contract and the ABI for it. Again, this is the simple storage contract. I've just copied these values in here. This is deployed on Rinkeby right now. And let's go down to the bottom and hit it from the entry point, which is main. So it starts at main. So we just initialize Web3. We refresh a couple values, which is just pulling the selected address from MetaMask, getting the current balance for that address, then setting up a contract using the contract address and ABI that we specified. And then lastly, it's going to use the get method to pull out that stored value. And we're just storing these in globals right here for now. Okay, and then next it's going to display it, so it's just taking those various values and it's just popping them into the page, right, into those span tags where we had them earlier. The address, the balance, which is just got a little bit of formatting on it, but nothing special, contract address, and lastly, the value that's stored in the contract. And then the last couple lines of code here, just really basic code to initialize the buttons for setting a value and refreshing. Refreshing, let's take a look at that first. It's just refreshing the values and redisplaying it. Exactly what we did here, just redoing that process. And then the set button calls set value right here, which is just displays a message on screen, pulls the form value out of the set. This is an input here, the set input, gets the value. We pop that into the set method, which is on the contract, and we store that in the blockchain. And once we get confirmation that that's occurred, we're just displaying the link. So it's very straightforward, and the process that we just went through right here. Okay, so in the next part, we need to turn this into Godwoken. So the first thing I'm going to do is I'm going to back out and I'm going to make a copy of. Okay, my mic gave out for a second there. Okay, so first thing I'm going to do is I'm going to make a copy here. I'm going to copy the Ethereum to, let's see, let's call this Godwoken. Let's just call it Godwoken. All right, and then a CD Godwoken. Let's double check to make sure those dependencies are okay. And we'll start that. Okay, and then in our editor, we need to close this, and we need to open up our newer folder here. All right, so the first thing we're going to need to do is put in this line here, which is the polyjuice provider. So this is kind of like a go-between between Godwoken and Web3, there's a little bit of things that are a little bit different, and so this is kind of like a shim. It goes in between the two and makes and bridges that compatibility. Okay, and the next thing we need here, we're going to need to change this contract, because the contract is the same, but it's going to be at a new location, because this is going to be, we're going to be interacting with layer 2 here. So I already have my own a new contract ready for that we're going to be using. That's was deployed again that was task 2 to deploy the Ethereum smart contract to Polyjuice. This is that exact same thing, except I've already gone through that process. And the ABI, we don't need to change that because it is the exact same smart contract. Okay, and so now we're going to go down to the bottom here, and we're going to need to initialize the provider. And so I just pasted in the code for that. We're just taking the Godwoken URL, and let's see, did I put the Godwoken? No, I did not put the Godwoken URL. So we need the Godwoken URL. This is the provider URL that we're using for the Godwoken testnet. And so this would of course be different for mainnet later on, but Godwoken's still in testnet, so this is the one we're working with. Okay, so we set up the Polyjuice provider. In there we provide the Godwoken URL just exactly like this. That sets a provider. This goes into Web3 when it's initialized. And then we can get rid of this line here. We no longer need this. We're using the Polyjuice provider. And then we go ahead and enable it just as normal and go through the rest of the initialization process. Okay, so let's see, with refresh values, I don't believe that we actually need to change anything here, because Web3 is being used as is, and it should everything should come out about the same, except the balance is going to be slightly different, because it's going to be pulling in the CK bytes in Shannon's rather than Ether in, I'm not sure, I use it from Way. Yeah, it uses Way. So there's going to be a difference in the number of zeros, which we're going to take into account, but the calling of the contracts and everything should be exactly the same. So then in display here, we will need to make a change here for display. It's like I said, the number of zeros in there for Ethereum and CKB are going to be a little bit different. So here, I just pasted in a line here, so you can see that instead of using the Web3 utils to convert the zeros and into Ether, the way into Ether, we're just using the balance, and we're dividing it by, this is 100 million here, which is because there's 100 million Shannons in a CK byte, just the exact same way how there's 100 million Satoshis in a Bitcoin. So our value is the same there. So we're just going to apply, divide that so we get the CK byte value, and apply some basic formatting, and of course tag on the CKB extension. And we can get rid of this line now, because we're no longer displaying Ether. Okay, and then once, let's see, when we want to send a value, set a value, that's when it gets a little bit different. We're going to need to do a couple things here. First, we have to do some default set options. So let's see, let me paste this line in here. So this is setting a relatively high gas price here, and using this default send options. If anybody out there watching did task 7 before, you may remember that this was a little bit more complicated, I believe. This is part of what's actually been simplified, and so, but it's still necessary at this point. So this goes into the send options object here. So we just drop in that like that. And then we also need to remove the link here below it, because this was making a Rinkeby Etherscan Explorer link, but we can't use that because we're not dealing with Rinkeby. We're going to be dealing with Godwoken. Now Godwoken does have its own Explorer I've actually used it. It's in a private beta at this point. It's working fairly well, but the developers are not ready to release it to public, so we have to just display the transaction hash for now. And then we're going to go ahead and make one more change to this, which is to display the Polyjuice address as well. Now, in most cases, you're probably not going to need to do this because most users will be, if they're coming from Ethereum, they'll expect to see their Ethereum address, and that's fine, but we're going to add this in for completion here. So what I did is, this is just the address translator that we need for the Godwoken integration tools package, and we're just going to call that address 2 here. We're going to display 2 addresses, and I'm going to add in a second line down here. Okay, so what this is doing is this is taking it's making a new address translator, and it's just calling this method on it, which is it's changing the Ethereum address to a Godwoken short address, and you just feed it the current Ethereum address, which is in turn which is coming out of MetaMask. So it's really pretty simple. It is a two-way transition that should be able to happen, and there might have been a limitation about the Godwoken had to be the Godwoken account had to be initialized first, but I'm actually not sure if that's a requirement anymore. But anyway, it's it should be a one-to-one here, and you can go in the reverse too. But since we're using MetaMask, there's not any real reason to, because you're already going to always have the Ethereum address. And the last change we need to make is we're just going to need to put a field in for it. So we'll just copy the Ethereum address and put it in as Polyjuice. Now, it's not a CKB address, you may have noticed, because a CKB address, that is for layer 1. We're dealing with layer 2, specifically the EVM compatible layer 2, which means Polyjuice is the one we want. Okay, so we save that, and we'll save this one too. And we got an error here, cannot resolve Nervos. Oh, I forgot a step here. Very important step when you're dealing with this stuff is you need to make sure that you include the correct dependencies. So we have to add Polyjuice provider and Nervos Godwoken integration. I'm using, if you notice here, specific versions here, and that's because I know that these versions are going to be compatible with the current Godwoken testnet. And so the Godwoken is still making pretty rapid changes, so there may be some incompatibilities throughout these different versions, and you're just going to need to make sure that you're on the correct version of the tools that's working with the current version of the Godwoken testnet. And so we do our best to keep everything, all of the existing example code out there up to date. But when they do make changes, sometimes it takes us a day or two to get everything caught up. If you have any problems, you can definitely drop into the Discord channel and ask us, and we'll do our best to give you a hand with whatever you're having trouble with. So let's go ahead and add these into the add these as dependencies. And then we'll start the server again. And it looks like it built properly this time. Okay, so let's just reload this just to be sure. Okay, one more time. Let's try that. Come on. There we go. Okay, it went pretty slow there for some reason, but it did eventually come through, and it looks like Polyjuice address is still missing. Okay, why is that missing? Oh, because we didn't include it here. Okay, so I missed one line here. We need to populate that address field also. Okay, so while this is loading, it's for whatever reason, it's taking a little bit longer than it usually does. It's usually pretty quick there. I'm not sure why it's slow right now. So One thing I want to mention here, though, is like I'm still on Rinkeby here, and I did not use Godwoken testnet. Now, if you did task 7 before, you may remember that Godwoken testnet was something that you had to set up as a custom RPC. So that is still part of the official instructions, and it's still in task 7 for reference here. But I found that I didn't actually need it for this example, so I decided not to even change it. Because it doesn't, for whatever reason, like it hasn't been, the integration hasn't been fully completed yet, is what I'm guessing. Like if I select Godwoken, like my balance here is still 0. And like it'll say 0 ETH or 0 CKB, and when I clearly actually do have a balance there, you can see it on the screen over here. So rather than even bother with that, I've just been leaving it as rank B, and for this example here, it seems to work fine. In the future, that may change. It may require that custom RPC, but you know, we'll just have to take that as it comes. So let's see. The current value in the contract is 2, and this is so here's my ETH address. Here's my Polyjuice address, which is again a 1-to-1 with the ETH address. I have already loaded that with some CKB. And this is the contract address, which was the same exact simple storage contract that has been loaded onto layer 2. And let's just try setting the value. Let's set it to 3. Okay, so here's our confirmation screen, and you may notice that it doesn't have the same amount of information here. You're just signing a basic message. This is normal. This is something that, again, that may change in the future, but at present time, just seeing this basic information here with just a message hash that you have to sign is what is actually expected. So we just sign that, and it'll usually take at least a couple seconds here. It's been broadcasted to layer 2 now, and we're just waiting for it to get picked up and confirmed. Okay, so now we have a transaction hash, so it has been confirmed out there, and we don't have a Godwoken Explorer is not quite ready yet, so that's why we just have a hash here. So now when we refresh, it should go from 2 to 3, but sometimes it does take a little while. It worked this time. Sometimes it can take a couple more seconds, you know, just as things propagate. So if you hit it and it doesn't immediately work, don't just give it a couple moments more and then hit it again. Okay, and that's the basics of it. At this point, we have made the major changes that we needed. Really, like as you see, it was pretty simple. The most important thing was just getting that provider in there. We just had to get the Polyjuice provider, which goes in basically as a shim into Web3. And then we had to do a couple things for address translation. Just that's a cosmetic issue about how it displays properly for the balance. And we had to add in some default options for the send. And the Polyjuice address translation, that's completely optional. Like I mentioned, at this point in time, I don't think it would serve that much of a purpose for many things. In the future, it may or it may not. It's not quite clear at this point. But for most of your users who are just expecting to do, for example, basic DeFi, they probably don't even need to see their Polyjuice address. Okay, so now that we've covered that, the next thing I'd like to do is actually just walk backwards here and say, like we have a working script here. What were to be the error messages that were received if we had made some errors? Just because during the hackathon we were giving support out, and we had a lot of people that had very basic problems, and it was usually just because something was basically out of place, a wrong copy and paste, a wrong value here and there. And so let's just go through a couple of those. Like the first one here is, what if you had an address that didn't have a balance on it? Let's see what that would look like. Okay, so now this pulled up. Here's the new address that I just selected, and it has 0 CK bytes in it. Now, if it has 0 CK bytes, that also means that the Godwoken count was probably not initialized, and it doesn't actually exist on layer 2. So while it does display everything just fine right now, if we actually tried to set a value, we may actually, yes, there we go. We get an error here, kind of a little bit cryptic here and hard to understand. GW get account ID by script hash is null. And that's confirming what I said, which is just the Godwoken account doesn't actually exist yet because the deposit was never made. Okay, so now let's change this back to the account that we know that does have something on it. And let's try it with a contract that, that doesn't exist. In fact, let's open up the Ethereum contract. Okay, so I'm just copying the Ethereum contract so that we could just see what would happen if it was a contract that doesn't exist, because this is the Ethereum contract, not the Godwoken one, so it's at the wrong address. What would it do? Well, here it would give you this error, which is again another one of these kind of cryptic. GW get account ID by script hash is null. And so we should have the correct address here, which was account 2 is the one I was using. That is a valid Godwoken address. But it just doesn't work because we're now using the wrong contract. Okay, so if we change that back and we save that, then we should get this to load up properly again. There we go, with my current balance and everything. And last one I want to check is let's say that somebody copy and pasted the wrong URL here, the wrong web provider or something. So let's try a domain that doesn't exist. I just put a .com on there. And now we're getting this error here about CORS at request blocked. And it's because the CORS request did not succeed. Now, we'll change that back. There's actually one other thing that could cause that, and that's sometimes if you have HTTP instead of HTTPS, that can also cause a CORS error. But sometimes it works, which is we didn't see this. Not everybody got the error, which was kind of strange. Is sometimes using it without HTTPS worked for people, and sometimes it did not. So here, let's try it. Let's try it one more time here. Let's try to set it to 4. Let's just see if this works. Like I said, the error was not consistent, but we always recommend using HTTPS now, just in case, because that seemed to work 100% of the time, whereas for whatever reason, 50 to 75% of the time, HTTP alone would work, but not always. And right now on my screen, you're watching it work fine. I'm not sure why it's working fine. It just is. Probably because that's going through. No, I can't. I'm not sure at all why that's working. Like this should all be in the browser code. Maybe they changed the headers, the cores, or something on God. I'm not sure. But anyway, it's working now. Let's just make sure that we keep using the HTTPS because I believe that's what the current expected URL should be. Okay, and we'll just refresh that to make sure it's still working. Okay, and so let me go back to my notes screen here. There's just a couple things that I wanted to touch on just before we ended up wrap up here. If you have not gone through part 1 of the bounty, the part 1 of the hackathon, which was the bounty program, it's definitely still worth it if you didn't, because it shows you the basic steps that you're going to need to do some of the initial actions of setting up a Godwoken account. And these are things that you're going to have to do for your users to be able to help move these things across the different layers of Nervos from layer 1 to layer 2. And there's also some good ones in there for Force Bridge as well, just showing what's going on and what's in our ecosystem and how it's going to work. All of the tasks are still available here at this URL, and we continue to update those for the time being, just to make sure that all those instructions are still available for anybody who needs it. And the previous React version that was task 7, the examples for that are also continuing to be updated. And those are these 3 repositories here. So Ethereum simple is these are all the same thing. It's the same kind of code that we just very simple, similar to what we just did, but with slightly more code and involvement there. Like this is one that uses Ethereum, React, and TypeScript. And while as our current example did not have React or TypeScript, it was just basic Ethereum. And this has the reason that this is going to be important is because of the build system. I believe that this uses CRA, Create React App, and it has the changes in it for anybody who's working with this similar stack. They may need to pull out some of the settings there, especially like the Webpack settings, so you can get everything configured and compiled correctly. The second one here, Godwoken simple. So this is the same as Ethereum simple, but it was properly ported over to Godwoken, and that's using TypeScript as well. So when you're looking for a Godwoken example using React and TypeScript, if that's similar to the stack you're using, especially if you're porting over an existing application, an open source one that you found somewhere, this is probably the one you're going to want to go to. And you're probably going to want to look in this repository for some of the configuration things about, especially around like the Webpack configuration, the TS, the TypeScript configuration, things that really are in there to help it build. You might also need like the scripts, the package.json scripts in here that deal with the various things, starting servers and so on. Okay, and then the last one here is the same, Godwoken Simple JS. This is the same as Godwoken Simple, but with just plain JavaScript. So if you're working on just a JavaScript application that, for example, you found an open source piece of code that you want to work, a project that you want to work with, that's where they wrote it in JavaScript and not TypeScript, this is the same basic thing that we just went through. It has like all the Webpack build configurations, or at least it should, and except that this one does not have TypeScript in it. Yeah, so it looks like this one is just using a rewired React and some Babel loaders, and where is the I don't see a Webpack configuration in there. Maybe it just works. It probably just works standard without actually having to modify that, which is oh wait, well, here's a couple changes. Anyway, if you have any questions about these, this guy right here, Daniel Kamak, is the guy to ask. He's on Discord. He wrote these, so you'll want to talk to him probably about that. And he's the guy who's going to be the most up to date on most of the Godwoken stuff. So definitely try to catch him in the Discord if you can. But any of us are available for any of your questions, especially if you have any basic questions about this demonstration here today. I'll be in the Discord as well. And that's all I got for you today. So if there's any questions, just feel free to ask them. Otherwise, I think we're ready to wrap up.